Set my screen. Let me start my document camera. Okay, we're on page 434 in your science book. Page 434. Okay, and I just wanted to go over this. We've been talking about earthquakes all week, but they also use this scale when they talk about earthquakes that has to talk about magnitude or how strong they are. And I wanted to go over it because next week in math, we're actually going to be talking about exponents and powers. So, comparing earthquakes, scales are used to describe, I think we need more light. Is that better? That's a little bit too bright. I don't know. Okay, so scales are used to describe and compare things. For example, you could rate something on a scale of 1 to 10. In science, different types of scales are used to describe the natural world. A linear scale is a scale that would be familiar with you. Each step along a linear scale is the same size. For example, on a ruler, 2 centimeters is twice as long as 1 centimeter, and 3 centimeters is 3 times as long as 1 centimeter. Another type of scale is called a logarithmic scale. See the steps below to learn more about logarithmic scales. My mouth is not working today. Okay, sample problem. Reading the scale. God bless it. Logarithmic scales are used to describe things with a large range of values in a meaningful way. The scale below is a base 10 logarithmic scale. Identifying relationships on a logarithmic scale below, each step shows an increase by a factor of 10. So it's 10 times. So every step you take is 10 times more. Jacob?
Yes.
Book 434. Calculating logarithms. The colored boxes below show how each value along the scale can be calculated. The smaller number after the 10 is an exponent. And that's what we're going to be talking about next week. So this little number right here, that's an exponent. 10 to the 2 means 10 to the power of 2, and the exponent is 2. This means 10 is used as a factor 2 times. So 10 to the 2 to the second power, that's how they say that, 10 to the second power, is the same thing as 10 times 10, or 100. Any number, I'm sorry, to the power of 0 is equal to 1. So if you had 10 to the power of 0, that is equal to 1. Or if you have 5 to the power of 0, that is 1. Kind of weird, right? I can't really quite explain that. There is an explanation for that. Or if I have 4 to the power of 0, that is equal to 1. Okay, we did that. Applying concepts. Look at the cubes above the number line. For each step, the number of cubes increases by a factor of 10 because we're using a base 10 logarithm. Okay, so here I'm going from 1 to 2, right? So this step is 1. So I'd write that as 10 to the first power. Let me move this up. So this is 10 to the first power. So that's 10. You're just doing 10 times 1, that's 10. Position 2 is 10 times larger than position 1. Okay, so here I'm going from here, if you follow the blue line over here, this is 2 steps from 10. So this is 10 to the second power. So this is 10 times 10. So this is 100, right? So this has a value of 10. This has a value of 100. Position 3 is 100 times larger than position 1. Okay, and then if we go the next step, if we go to 4, right, this is 3 steps. So that's 1, 2, 3 steps. So that's 10 to the third power. So that's 10 times 10 times 10. So this has a value of 1,000. Position 4 is 1,000 times larger than position 1. Okay, so this is a logarithmic scale. And this is the kind of scale that they use to measure earthquakes. Okay, so back up here at the top of this page, earthquakes happen when a section of rock moves along a fault or a break in Earth's surface. This motion releases energy and causes the ground to shake. The magnitude or size of an earthquake can be expressed using the moment magnitude scale. I think they also call it the Richter scale. Moment magnitude scale. Just like the scale on the previous page, this is a base 10 logarithmic scale. Each step represents a 10-fold increase in earthquake magnitude. This scale is used because there is a very large range in earthquake magnitude. So you're using this because there's such a huge difference between all earthquakes, and you want to capture that, right? You don't want to get these really crazy numbers. Okay, so this is a base 10 logarithmic scale used to represent earthquake magnitude. So for example, on this scale right here, they actually have some current events of earthquakes. So in northern Texas on January the 6th, 2012, apparently we had an earthquake, a 2.0. I don't remember that, but I wasn't here in 2012. Okay, so then in New Jersey in 2009, they had a 3.0 earthquake. Haiti, you remember Haiti in 2010? It pretty much devastated the whole island. That was a 7.0 magnitude earthquake. And then this is Yakout Bay in Alaska. This was in 1899. That's a pretty long time ago. That was an 8.0 earthquake. And then the Great Tahuka earthquake, and this was in Japan in 2011. Okay, that was a 9.0 earthquake. So you can see there's a huge difference, and each time it jumps by a factor of 10, right? So reading the scale, what type of scale is shown above, and what does the scale represent? So this is the logarithmic scale, right? And it's representing the different magnitudes of the earthquake. So this is a base. This is a base 10 logarithmic It's log and arithmetic added together. So this is a base 10 logarithmic scale, right? And it's measuring earthquake magnitude. Okay. Number 2, identify relationships. How much does the strength of an earthquake increase with 1 step on this scale and with 2 steps? So for each step, 1 step, It's 10 to the first power, or 10, 2 steps. That's 10 to the 2 second power, 10 to the second power, which is equal to 100. So it jumps 100. So from here to here, it jumps 100. Calculating logarithms. Draw an arrow under the number line from the northern Texas earthquake to the New Jersey earthquake. So we're going to go from here to here. So we're going to draw a line like that. Yeah? Oh, I'm sorry. So I went from 2 to 3. I just drew a line. Below the arrow, write the number of steps between the 2 earthquakes. So this step here was 1 step, right? The number of steps is equal to the exponent. Remember that this is a base 10 logarithmic scale. How much larger is the magnitude of 3.43a? Okay, so this is 1 step. So this is 10 to the first power. Well, now they're saying, let's compare northern Texas to Haiti earthquake. Okay, so if we go from here, say we go from here to Haiti, right? How many steps did we take? We took 1, 2, 3, 4, 5. So this will be 10 to the 5th power. Okay, difference from the North Texas earthquake. 10 to the 5th power. Okay. And if we went from Texas to Alaska, so if we draw another arrow here, how many steps is that? That's 1, 2, 3, 4, 5, 6. So this would be 10 to the 6th power. And then if we go from Texas to Japan, draw another arrow. How many steps? 1, 2, 3, 4, 5, 6, 7. This would be 10 to the 7th power. Okay? And each one of those, that's 10 times 10 times 10, 7 times. So this is the same thing as 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7. That's what this is equal to. Pretty big number. But you could just add zeros, right? So you can take... So you could put a 10 and then you can just add zeros. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2. So that's 100 million times difference from North Texas to here. That's 100 million. That's a big difference. Okay, number 5, applying concepts. Explain why a logarithmic scale is appropriate to display earthquake magnitudes. Okay, a logarithmic scale a logarithmic scale is appropriate is appropriate because there is a large range of values that describes the size of the earthquake. Okay. Okay. What time is it? 9 o'clock? Okay. So that's from that page, we just go into the chapter. We've done the chapter already, right? And we've done set you up for the quiz. So what I'm going to do is I'm going to let you take the rest of the period. If you have not finished your quiz, you need to finish your quiz. You have an Ed puzzle, you have a Generation Genius. And then actually tomorrow, Thursday, we're going to go over this in class. Little section. And then when we do that, we'll be ready for next week where we start the solar system. And we'll probably just do a Kahoot on Friday. This is a short chapter. Okay, so for the rest of the period, that's 25 minutes. If you haven't finished your quiz, finish your quiz. If you haven't done your Ed puzzle, do your Ed puzzle. Generation Genius. That's a pretty cool video. Talks about buildings and how they try to make them earthquake proof. I don't think there wasn't a science detective this week, was there?
On Ed Puzzle, you assigned a solar system Ed Puzzle lesson. Yeah, it's due this week. I was just, I wonder if it's like actually.
Well, let me see.
This week.
I could have very easily made a mistake. Science classwork. Sorry about that.
It's on the Ed Puzzle website.
Yeah, but I just want to see what I posted here. I did put solar system. Well, son of a gun. Okay. Well, that's weird. No. Here's earthquakes. No, I have an Ed puzzle. This is next week. I'm a week ahead.
Well, yeah, so you put down the right Ed Puzzles, but you put an extra one. That was...
Yeah, there was one that didn't work, right?
Well, there was one Ed Puzzle from that's supposed to be next week that's assigned this week on the Ed Puzzle website.
Oh. Okay, so the problem's on Ed Puzzle website.
Yeah.
Oh, okay. Okay, well then I can't do that then. I was trying to get ahead. Oh, well, let me look. Maybe I can change the date is due. Maybe that's the problem. Ed puzzle.
It's in science.
Yeah. Content. The classes. Grade book. Maybe I go to grade book. And go to this is this period. There's earthquake. I did. Let's see if I can change I did. No, I have the wrong due date. You're absolutely correct. So let me change this to
March 9th.
on March the 8th through March the 12th. So, there we go. Well, thank you, sir. You helped me fix that. Okay, my online people, it is 9:25, you may log out and go to period 2.